So now that the proud papa has come up here and talked about his child, let's talk a little bit about what that child's contributing to society, right? How's this getting implemented? What's it doing? And so I'll start with the data center and just kind of work my way across to what we're doing, what kind of things we're seeing, and then have Alan finish it off with the campus. So if I look in the data center and I just start at the racks, start at the top of rack, right? It's where all my applications live. I'm going to have service chain elements there as well. And all this stuff is very highly mobile. Virtualized environment, even though it's all still mixed, we have some bare metal, other things. Everything needs to move around, including, let's take virtual appliances. So let's say I have a virtual ADC sitting in there. The point we're at today, if I move an application, literally the ADC instance associated with it will move with it. This is all good and well, except that once that moves, what do? You call the network. I need this port with these policies now. I mean, there are some levels where you can get some automation, but there's still a lot of manual intervention. And this is where we get into just, it's got to be fast and flexible. Right? This is the big piece about the fabric. And this is the big piece that Fabric Connect brings us. Because what happens when it's not fast and flexible is that the server admins, the storage admins, what are you going to do? You're going to go build clusters. You're going to build your own cluster. And it's going to be this self-contained unit out here with its entire own infrastructure. And then you're going to call me and say, Randy, I need 240 gigs into the network right here. And I'm going to say, 30 days, I got you covered. And it's still not good. But if I said, okay, I have these racks, and you'll forgive me, this is like 16 racks, but if you waited for me to draw them all, we'd be here forever. So I've got 16 racks. They're interconnected, cross-connected, right, in a partial mesh. And I said, okay, here's the thing. You have all of these assets sitting here. What if I told you, we can start with the simple stuff. You move a VM, and you move it from here to here, and the service automatically moves with it. So Paul was talking about the ISIDs and the VSNs, right? So that virtual service moves with the VM. All the policies associated with it go with it, right? Now that's the easy case. Go back to the storage and server admins, you want to build a cluster. So normally you would have built this cluster off to the side because I'm not fast enough. If I instead told you, find an empty slot. Go put compute in anywhere you want, or let's put a chassis in and let's build some nodal storage here. Right? Put the storage in anywhere you want. And virtually, you can take, even if it's some here, some here, some here, some here, doesn't matter. You can tie it all together and bring it in virtually into that cluster. Now, initially when you're building a cluster, maybe you already have space, you come in with a full rack or whatever, but last time I checked, this stuff is growing at fairly rapid rates. So in 3 months, when you need to add something else to it, you're going to need more space, and it's probably not going to be right where you wanted it. So having this flexibility is great. And the thing is, I don't want you building your own infrastructure anymore. This kind of ghost network out here that you just want to connect up to mine and I have no visibility or understanding of. So when I tell you to do this, I'm going to say, okay, here's the thing. By the way, I've got a policy engine sitting out here. It's not required for Fabric Connect, but let's get to the truth here. As we start to talk about automation and all these cool things, I want to be able to tie some policy around it. I want to put some fences up. So say, okay, you tell me what kind of things you want to connect, and your service is, service 17. And so anywhere you connect, any of the things you're looking to connect, service 17 is going to pop up. And so now it's not you calling me after you've built this cluster and saying, oh, by the way, Randy, I need a couple 40 gig ports. It's you calling me up front and saying, okay, I'm going to put these types of devices in here, right? Build me a profile. And when I launch them in, I'm going to put them in and they're going to drop into 17. And so now I build my cluster automatically. Right? You have that agility, right? You get that time to service. You get your cluster up much faster, and you have the flexibility that you're no longer looking for space or trying to build it off over here in some skunkworks area and connect it in. You can build it anywhere you need within this infrastructure.
You talk about multi-tenancy then, just a straight up multi-tenancy app.
So that's the next piece, absolutely. Multi-tenancy, you want isolation to it. But do you have more to the...
So what is the policy engine actually doing? You're talking about an arbitrary service number 17. Is that mapping down to an ISID? What is that?
Yeah, so yeah, sorry. I forget my levels. I've been analyst in media all day. I have to change a little. So this would literally be ISID 17, right? And now part of this is, what you told me is I'm going to bring this in, and this is going to be VLANs 27, 37, 46, and 89.
All mapped into ISID 17.
And I said, okay, anything that hits me, these VLANs, I'm going to map it into 17 for you. We're going to do a little policy check to make sure it's what you told me you were going to do, and we're good. And that's just going to self-create, and you can do whatever you want. Right? And then when Alan gets up here and starts talking about campus, whoever's using this at the other end can quickly go say, oh, I want to be on VLAN 37 for this storage service, and I want to be able to get to that. And they're done.
So let me push it a little further then. How does the policy engine tell the members of the fabric where that ISID is allowed? Is there some kind of filtering mechanism that's going on?
So now you're getting into a little deeper into policy, right? So at this point, you come in, I make a check against you, what you are, who you are, right? And that you're asking to be in this VLAN or this service. And very quickly go out and configure it, right? The part of containing it more, so, and Alan can catch me if I'm wrong because he's got a little more policies actually in his kit, is a little further out, right? That's not there today as to say, okay, you can be in this area but not this area, right? So you've still got development going on in this area, and frankly, from what I can see across this whole concept of automation and what we're doing, you can call it SDN or anything else, right? We still have development to do here to put controls on it. Okay? The other piece I'm going to throw out here is application performance. Because when you start putting applications on here, right, one of the big things we want to know wherever they're going across the service is what are the performance metrics of the service I just gave you? Okay? And so I have the ability then to measure across that service things like QoS levels, general OAM, right, loss, latency, jitter kind of stuff. And as we get a little further along into some of the things we're working on in here, you've got some feedback mechanisms that allow the app and the network to start communicating with one another, to make asks for those metrics, and then to report back on those metrics and make decisions if you're out of bounds on them. And that becomes really important because the whole reason apps exist is because users need to do something. And at the end of the day, you've got to get whatever is sitting here in 17 all the way across there to the next level. Now, the one thing I will mention here is this is distributed top of rack, right? It's all interconnected in a partial mesh. So you have most of the traffic anyway is going east-west. The 80%. Roughly, you make a web page, you do a simple get, and you end up calling 12 other apps just to get the web page. So you're going to have all high-speed links in here running between, Now what you're going to do is, if you want to go up, so you get into your core. Today, every rack would have dual uplinks. This is just the way I see things. This, though, is really just a network node. So maybe I don't need dual uplinks from every rack. Maybe I don't really need that much bandwidth, and I don't want to burn that many ports going up. So I'm going to come out of here in strategic locations, however much bandwidth I actually need to get up, and assuming there could be a failure somewhere, a little extra. I like to buffer some. Into my core. Now, this could be, I'm just heading northbound now, out toward the campus, or it could be that I'm going to drop back down into another network node just like this. And the size of this node, the reason it's 4x4, 16 rack, it's got nothing to do with scale limitations or anything else. This is literally a design concept. Because as I get beyond a 4x4, I start to push out beyond 3 hops. If I have 200 of these and I need to go from here to here, I'll be hopping all day to get to it. 3 hops is a pretty reasonable limit. So if I want to get out of the 3 hop, I pop up and back down into the next node.
Why did you do 4x4 as opposed to leaf spine?
As opposed to just pure leaf spine?
Pure leaf spine.
So because if I did pure leaf spine, I'm back to that concept of constantly going up when 80% of my traffic is inside this node.
Yeah, but still, if you want to go from the node on the left-hand side to the node on the bottom right, you have to traverse a few nodes, right?
To go from here to here? 3 hops, yes.
It's 3 hops. If you go to the spine and back, it's 1 hop.
It is 1 hop. So it's literally engineering to what acceptable levels of latency and stuff are for different applications. Now, you can put limits around if you say, oh, I'm so latency sensitive that I want to keep this application to a single up and down hop, or 2 hops practically. Then I can say, okay, maybe I want to lay it out like leaf and spine, or maybe I want to restrict where that application falls in here so that it's in a cluster that's only got 2 hop limit. Or both. Or you could change the 4x4, right? Maybe it becomes 2x2, 3x3, right? It's, again, this isn't a locked in. This is just a general best practices design principle when we start to look at how the applications flow.
Another question in the context of that 4x4, are we suggesting that only adjacent nodes in that grid can be wired to another, or could you hop around and wire it?
You could wire. Yeah, you could wire it any way you want.
Yeah.
It's just...
So sorry, I just don't see the value of this.
Yeah, I guess that's where my brain's trying to go too.
I mean, with leaf and spine, you get equidistant bandwidth between any 2 endpoints. So whatever east-west bandwidth you have.
So add to that, you have leaf and spine going up north and south, right, for traffic going. But if all the traffic's really going east and west 80%,
No.
Let me finish
Okay.
the thought. You like where I'm going?
Just turn it around like a regular cross fabric should look like before it was leaf and spine,
Yeah.
and now you will have it east and west if you want to see it east
So
and west.
the
Come on.
benefit of a fabric, so link-state protocols, it sees all links. That means that you can leave your leaf and spine and add cross links between your top of racks too, so that you can actually choose. You'll know the SPV will know the shortest path is either the 2 hops through the core, or you know what, the 3 hops might actually be a better path because
So you
they're
do
40 or
unequal
100
cost
gig, and this
multipath?
is 10 gig.
You do unequal cost multipath?
We could.
I know
don't
you
know if you want
could.
to. Yes,
The
it's
question
always
is,
supported.
do you?
Yeah, of course. But it stands right now that you do equal cost multipath.
Okay.
But here's the thing, to the point that we were just trying to talk on the side. If you have economies of port perspective, is that the cost on a modular box is a lot more expensive than the cost on a
I'm not talking about modular boxes.
I got you. Or, I'm trying to add the other things. Maybe it's 10 gig up and down and 40 gig across. So wouldn't you rather take a 40 gig path across than a 10 gig up and down?
Why don't you just pull 40 gigs up and
You
you're
can do
done?
that too.
So now you've done 40 gig everywhere, and you've probably got a lot more 40 gig than you
Exactly.
need. Again, this is about optimization, right? This is
Sorry.
It's an example. It's just one possible
Reference
design.
Yeah.
They can't. He doesn't have time to draw every single connotation and permutation.
good, but I'm not very good at drawing, and he did say I had a limit. So, right? Again, it's not that you are limited on the design. You have the flexibility to do everything. Right? It comes down to looking at the realities of how your traffic flows are and building to it. I will tell you, most of what you walk into out there looks like this. Or, well, technically, actually, I'll tell you what most of you walk into in enterprise is there may be 30 to 80 servers, and I would do a much smaller design. It's never going to get to this size. So,
You need 2 switches.
yeah, exactly. So step up to the core. Now, whether I have other nodes or whatever, so Paul jumped into the modular thing, which I always love. So traditionally, what do? So when I started in the industry, I started in a big LEC. So everything was 5 nines, traditional telco standards, and how do you get that stuff? You get it with hardware. So build modular boxes, put lots of redundancy in them, give the resiliency there. We still do it today, simply because it's the way we've always done things. We're starting to see some shift in the industry. The truth is, if you've got the resiliency in this architecture, if this architecture is more bulletproof than an actual box, individual box, then why not build this with more compact form factor type boxes?
Two simpler fixed config switches, you lose one of them, you still got your redundancy, and instead of replacing a supervisor engine, you're replacing a fixed configuration switch.
Exactly. Keep this to a 2U box. Something simple, right? The port densities today with the chipsets are crazy, so it's not a problem to get the kind of port densities you need. Throw a few boxes in there. Your operational costs are dramatically down. Your CapEx costs dramatically down because it's just a much simpler design, and the resiliency comes purely from the fabric, right? Now you can take this, you can either do your collapsed core, data center, and enterprise. You can shift out and you can have separate cores, right? But then what you do is, again, this application is trying to reach that user down there. And so all these kinds of things we're talking about with policy, application performance, the service has to extend from end to end. And so that's where I'll hand it to Alan and let him talk a little bit about what's going on at the other end of the service.